Number 5, broken access control. In order to understand broken access control, it's best to understand the difference between authorization and authentication first. So OWASP top 10 number 2 that we talked about was broken authentication. Authentication was just proving a user is who they say they are, such as username and password or a driver's license. However, the process of authorization is just simply the permission to access resources. It's just determining what permissions that user has after they've already authenticated. So authentication happens, then authorization. Access control, however, the term access control means the process of authenticating a user and verifying authorization, then granting access to resources. So there's 3 parts basically. The authenticating, which we're not talking about in this vulnerability, that's covered in number 2. And then verifying authorization, then granting access to resources. So we're focusing on number 2, verifying authorization, and then 3, granting access to those resources. So that's what's covered here in number 5. This type of vulnerability occurs when the app fails to properly verify authorization to resources, which then allows an attacker access to restricted places and or data. So it's pretty bad. It's basically as bad as number 2. These are just split up in the OWASP top 10, I think, because together they would be too much to cover in just one vulnerability. So for an example in a web app, while using a web app, an attacker might notice an interesting parameter used in the URL. In this case, this is an account name, ACCT equals bblodget. So that's me. So a malicious attacker might think, what would happen if I change this parameter to somebody else's name? Will it let me into their account? So they just simply change that URL in their address bar of their browser to say admin, for example. If the app actually handles access control properly, an error of some kind should display, or maybe better yet, nothing at all should display and nothing should happen because that's something malicious. You might not want to tell your user or the malicious attacker any more information at all. So if your app doesn't handle it correctly, the attacker might be able to easily switch between user accounts. And it seems like a really dumb issue, but this has happened countless times in the news and continues to happen to this day. There's a reason why it's in the OWASP top 10. This specific vulnerability with an account name displayed in the URL like this, just in plain text and easy for the user to see, highly noticeable, is referred to as insecure direct object reference. And there's a whole cheat sheet for those that OWASP has developed. It's really, really good. So we want to talk about the impact of broken access control now. A lot of these are really going to be similar to number 2. The primary one is privilege escalation. So the attacker gains access to system accounts. Obviously, that's really bad. Then they can pretty much own the server and do anything that they want to. It can also lead to data leakage. It might not lead to complete system ownage. The user might be able to, not switch to an admin account or any other system account. They might only be able to switch to other regular user accounts, but that's still bad because those users might have sensitive information stored in there, personal information or health record information, depending on what your app is doing. This could be really bad. An attacker could also change the access rights for their user account. So they could essentially sort of plant a backdoor that they could use later. So if they change their normal user account to have access to all these admin pages or something on your web app, you might not even notice it, and that malicious attacker can use that account as a backdoor later on. This is a little diagram depicting an example from the real world. The guy on the right looks vaguely similar to Arthur Slugworth from Charlie and the Chocolate Factory. And the person on the left is a raver who's looking to get some extra money for some tickets to a show they want to go to. So they hack in their spare time and steal some data and sell it on the dark web. This does happen all the time, and this is actually more realistic than you might think. But yeah, that's what happens. Like other vulnerabilities, it can lead to ID theft, all kinds of fraud, and stealing of company secrets. So for prevention of broken access control, there's some best practices we can follow. The top best practice for this would be use proven and tested libraries and modules for your access control. And what that means is you probably don't want to write your access control yourself in your code. Use something that's been well tested and hardened and by other experts in cybersecurity. Something that's preferably open source and has a wide user base and community, because then it has the best chances of having all the really bad vulnerabilities fixed. You don't want to use something that was just written by somebody 15 years ago and they released one version and haven't come out with an update since then. You want to also log access control failures or suspicious or frequent activity. That's important just so that you can know when your app is being attacked. And don't forget to alert an actual human for serious access control failures. So make sure that somebody is actually monitoring or reviewing the alerts if you're logging them. If nobody ever looks at them, that's bad. You can't respond to what you don't know about. You can also rate limit API access to minimize the possibility of automated attacks. And I think I mentioned this earlier as a preventative measure for another one of these vulnerabilities, but you want to rate limit the API access, meaning delay or increasingly delay failed login attempts. And that's just so that a malicious attacker can't brute force a user's password. Because if you don't rate limit anything in your app, you might not discover it until the state of Illinois discovered that their voter registration database had been breached, when they start getting complaints from users that the database is slow. For further reading, you can reference the OWASP Insecure Direct Object Reference cheat sheet that I mentioned earlier. There's also an access control cheat sheet and a testing guide for authorization testing. That's really good, and that's actually, if you want to learn how to do bug bounties and how to break authentication or authorization, look at that testing guide.